Okay, to start off, milling is a machining process where we remove material using a rotating cutter to get precise shapes and dimensions. For this lab, the main issue we are focusing on is dimensional drift. This happens during long production runs where the size of the parts is slowly changes from what we actually want. So, even though the machine is doing the same process, the dimension at the start and the dimension at the end can be slightly different, and that is what we are trying to understand and analyze. Looking for slide 3, what is dimensional drift? Dimensional drift is basically means there is gradual change in the part of dimension over time. It doesn't happen instantly. It's small at first, but as the production run gets longer, these small changes start to accumulate. This drift usually comes from things like heat build up during cutting, the tool slowly wearing out, and minor changes in the machine setup. All these factors add up and cause the final part to differ from intended measurement. So next, we are looking at slide 4, why accuracy matters. Accuracy is really important because even small dimensional errors can affect how the parts fits during assembly. If it is too big or too small, it might not align properly with other components. Maintaining tolerance is also a key of quality control. If the machine gets outside the specified range, the part is basically considered a reject. And lastly, accuracy helps reduce costs. When the dimensional drift, we end up with more scrap, more work, and more time wasted. So controlling the dimensional drift directly improves production efficiency and overall product quality.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Ahmad Sofian Sulaiman, B13510323. Ni saya nak present pasal causes one is thermal expansion. Our first challenge is thermal expansion. This happen because cutting generate heat. The immense friction and energy involved in cutting metal, the temperature to rise, not just in the chips but in cutting tool and the workpiece itself. Think of how hot a car rotor get the same idea, just happening right at the cutting edge. The effect is dimension error. The critical effect is that this temperature increase cause slight dimension growth. According to the laws of physics, a hotter object expand. This means if we measure a part while it's hot, its dimension is temporarily too big. Then when the parts cool back down to room, temperature is shrink. This lead to the final parts being smaller. That attends on the finish and cool immediately falling tight tolerance. And mitigation, controlling temperature. The solution is to control the environment and the process. Use coolant effectively. We must float the cutting zone with coolant to carry the heat away as quickly as it generates. Secondly is temperature control. Machine and inspect the part is unstable. Temperature control. Room often 20 Celsius or below and that. That's all for me. And next, I want to present about cause 2 is toolware. The mechanism, our second cause is toolware. The statement is simple. Continuous cutting wear tools. The sharp edge degrade, the abrasive rubbing, high temperature, chemical reaction, and chipping this cause the cutting edge to become dulls. The effect on quality, the effect of a dulls is twofold. Firstly, inaccurate dimension. A one edge require much higher cutting force to remove material. This increase force cause tool and all the workpiece to deflect, bend or push away from the intended parts. This result in the tools cutting slightly inaccurate. Secondly is inconsistent surface finish. Instead of cleanly sharing the material, a dull edge rubs and tear is producing a raw, unacceptable surface finish. Mitigation strategies. Since we're inevitable, we must manage tool life proactively. Proactive replacement. Establish a restrict tool life limit based on the number of part or time, and replace the tool before it begin producing scrap, not after. And second is monitoring. Utilize in process monitoring. Example, spindle load sensor to detect sudden increase in cutting force, which signal excessive work and trigger automatic stop or replacement. And thirdly is tool material selection. Employ advanced tool coating and materials like ceramic or special carbide engineered for height wear resistant against the specific workpiece material. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Iskandar Muhammad Kami. Alright, I would like to discuss about course 3 machine and setup issues. Okay, so machine and setup issues have another reason. Dimensional drift happens is because of the machine itself. Over time, small things inside the machine start to change. For example, the spindle might not spin perfectly straight. The fixtures may loosen a little, or there might be tiny gaps in the machine movement. Okay, these issues might look small, but when you're producing many parts, they slowly add up and affect the final dimensions. Alright, secondly, the environment also plays a big role. If the cooling isn't consistent, the machine vibrates or the room temperature change. The cutting process becomes unstable. When the machine isn't working in a steady condition, the measurement of the parts begin to drift. Alright, and simply put, when the machine or the environment isn't stable, the dimensions start to drift, and after many parts, the errors become more noticeable. Alright, move to next slide. I would like to talk about how to detect drift. To detect dimensional drift, we basically compare how the parts change over time. One of the easiest ways is to check the first part and the last part in a production run. By measuring both using tools like calipers, micrometers, and CMM machine, we can see if the dimensions have shifted. Another method is using SPC charts, where we track the measurements during production. If the line on the chart starts to move upward or downward, it shows that drift is happening. We can also monitor the process itself, things like temperature, tool wear, or machine behavior. If we see unusual patterns or rising temperatures, it's a sign that drift might be starting. In simple words, we detect drift by measuring parts over time and watching for change in the machining conditions. Thank you.
Alright, Bismillahirrahmanirrahim. Today I will be presenting about the effect of drift in manufacturing process. First of all, drift can cause out of tolerance parts. This happens when parts are no longer match the required design specification, making them unusable and directly affecting the product quality. Secondly, drift also can increase the scrap rate. As machine accuracy decreases, more parts become inconsistent and fall outside the acceptable limits. This results in wasted material, higher production costs, and reduced efficiency. And last but not least, Drift also can lead to poor reliability. Even small dimensional changes can affect the performance of components, potentially causing yearly failure or reducing the overall lifespan of the product. In summary, drift affect quality, cost, and product reliability, which is why it is important to control and monitor it throughout the manufacturing process. That's all from me.
Okay, now I will explain the method used to reduce dimensional drift in machining. We divide the reduction strategies into two main categories: process control and maintenance technology. Process control. The first method focus on how we can operate the machine. First is machine warm-up. When the machine starts cold, the component slowly expand as they heat up. This temperature change cause a drift. By warming up the machine beforehand, we can stabilize the temperature earlier, which helps reduce thermal variation during actual machine. Second, coolant stability. Coolant play a major role in controlling temperature. First, consistent coolant flow and stable temperature prevent overheating, which means the tools and machines stay more accurate. If the coolant temperature change too much, drift increase. Third is optimize parameter. When we choose a proper feed rate to a spindle speed, it avoid unnecessary heat generation. Less heat mean less expansion of the machine part and tool, which reduce drift. It also minimize tools wear, tends to cut inaccurately. So overall, a good process control helps a machine maintain and more stable machining environment. Second is maintenance and technology. The second method focus on the machine physical condition and digital composition. First is a schedule tool replacement. Tool wear out over time, and worn tools cause a dimension inaccuracy. By replacing tools before they wear too much, we maintain the consistent cutting precision. Second, regular machine calibration. Calibration ensure the machine mechanical component remain aligned and accurate. If calibration is ignored, drift become more larger and more unpredictable. Third is CNC composition technology. Most CNC machines use a software to automatically adjust the cutting pad in real time. This composition help correct dimensional error as they happen. It's like the machine continuous fine-tuning itself to counter drift. Overall, this combination of maintenance and advanced technology great to minimize drift and effect. Slide 11. Conclusion. To conclude, the key point to remember is that drift is unavoidable. It's naturally occur due to heat, wear, and variation in machine components. No matter how advanced the machine is, some degree of drift will always be present. However, the important thing that drift can be managed and controlled through the proper process management, continuous monitoring, and regular maintenance. We can significantly reduce its impact. And when these methods are applied effectively, the outcome is improved machine accuracy and better product consistency and overall more reliable result. So even though drift cannot be completely eliminated, we can still keep it under control and ensure high quality machine performance.